6. Force. Force is mass times acceleration. Mass times acceleration. Mass times acceleration. Now, the quantity that we got mass from is mass and what? Acceleration. And how? We multiplied mass and acceleration and we're able to get our force. Now, the unit of mass is what? Kg. Unit of mass is kg times acceleration meter per second square. Right? It's the same thing as kg over meter per second. Sorry. It's the same thing as kg times meter over second square. That is acceleration. Okay? Now, but the unit of force, force has a particular unit apart from this, but that unit still means this, and that is newtons. That is what? Newtons. So from this you have seen that Newton is equal to what? Kg per second kg meter per second square. From this derivation you have seen that Newton is equal to kg meter per second square. Now, be that we know that the quantity that gave us mass is mass, force is mass and acceleration, and what we need to get force is to multiply 2. So we can now go to the dimension. The dimension of mass is what? Capital M. And the dimension of acceleration is what? L, right? T raised to power minus 2. Okay? So the dimension now is what? M, L, T minus 2. This is the dimension of force. Okay. Now, we'll go to another topic, point number 7, pressure. I just want you to have all these things at the back of your mind, because we are going to make use of it. Pressure is mass, force over area. Pressure is force over area. So the unit of this pressure has a particular unit just like the Newton, and this Pascal is what? Pascal. PA. Okay? It's written PA. So from this you can get the derivation. The derivation of is just like the other one, kg meter per second square all over the area. Unit of area is meter square. So Pascal is the same thing as kg meter per second square per meter square. So the dimension is now force is what? Tell me. Mass times acceleration. So mass L T raised to power minus 2 all over N raised to power 2. Okay? So if you want to divide this straight, you can divide this straight. So this one L will cancel out one L, right? One L will cancel out one L. We have M, or let's solve it proper. One L will cancel one L. We have M T raised to power minus 2 over L, which is the same thing as M T raised to power minus 2 raised to power minus 1. And that is the dimension of pressure. Energy. Number 8 is energy. Energy is force times distance. Energy is force times distance. We have our unit, the unit of force. We have the unit of force to be Newton, which is equal to what? Kg meter per second square, which is kg meter per second square times distance. Distance is what? Meters. Okay? Distance is meters. So if you want to multiply this, what do you have? You have kg meter square per second. But we have one value just like force, and we call it joule. We call it what? Joule. We call it what? Joule. And that is the unit of energy is in joule, and joule, which is represented by J. Then dimension is now what? Since we have that is force times mass times acceleration that form the force, right?
Yes.
Mass times acceleration, then mass times what? L raised to power minus 2. Mass times acceleration, that is the dimension of force, and our distance times what? Capital L. So the dimension of energy is ml square t minus 2. This is the dimension of energy. Now the next one, I hope you are following wherever you are. The next one is power. Next one is power. Power is from what? Work done over time taken. That is power. Time taken. If I like and I stand here for a very long time I'm holding this for a very long time and without changing a distance, I've not done work. So I've not exert any force on it. So before you can say, hey, this man did a lot of work in farm, you have to see the work done, is it not? Then you now calculate how many days did it take the man to do that work before you say this man has power. Not that someone will have small portion of land and cultivate on the land for 5 years. The person doesn't have power now, right? So before you can calculate the power of that person or power of the machine, then you check the work done in the farm before you will be able to, and the time taken before you are able to draw a conclusion that you have enough power or not, right? I'll still come to that when we go to power as a topic proper in physics, but now I'm just teaching you units and their dimension. Okay, so it's work done over power. Then this power, how do we get work done? Work done is force times distance. It's just like energy. Work done is force times distance. It's force times distance. So if energy is force times distance and this is the unit of energy, you have that work done is kg meter square per second square all over time taken is what? Second. Okay?
Yes, sir.
Time taken. You can't just cancel out this because this is per. Do you understand?
Yes, sir.
So you have to take it back to this your knowledge of indices. If you take it back to your knowledge of indices, what we have here is kg meter square all over second square all over second, right?
Yes.
So this thing is the same thing as kg meter square, okay,
Yes.
over second square divided by second, which is the same thing as kg meter square all over second square times 1 over second. Are you getting it now? So this is it. But power has a particular unit. It has a particular unit, just like energy, just like force, which is watts. Which is what? Watts. You write it this way, which is what? Watts. So from there you can get dimension of power using this knowledge now. So we have our mass. Our mass is capital M, then M square, capital M. Our distance is what? L square, then T raised to power minus 2, right?
Yes.
That is all over what? All over T, right?
Yes.
So having this knowledge here, we are not just going to cancel it out because what we have is what? Minus T. So what we have here is capital M, L square, T over T square divided by T, which is the same thing as M L square all over T square times 1 over capital T. Okay? So from this we now have our dimension to be capital M, L square and T raised to power minus T cube, right? And that's the dimension. So we have our momentum, mass times velocity, and after this momentum, momentum is mass times velocity. Momentum is mass times velocity. Momentum is mass times what? Velocity. And the unit of mass is kg, right?
Yes.
Then times velocity, which is meter per second. So this one is simple. It just, you combine it, you have kg meter per second. Now we go to dimension. Dimension of mass is what? Capital M. Dimension of velocity from meter per second, that is meter over second, right?
Yeah.
This thing is just like kg times meter over seconds. So if we use this knowledge here, we have kg, which is capital M, the mass, then velocity L times L, that is meter is measuring length, over T, capital T, which is the dimension of time. Okay, so with this we can have our dimension of momentum to be what? Capital M L T raised to power minus 1, using your knowledge of indices. We have other derived quantities like frequency. We have other derived quantity like period. We have other derived frequency is number of oscillation per time. That is your frequency. Then you see your frequency in sound, you see frequency in light. That's where you see frequency. Okay, you see your frequency in motion, right? Now you then period, you see your frequency in sound, your period in sound. Do you understand? It's a type of oscillatory. In oscillatory motion, you see your period. Okay? Period is another drive quantity. We drive period from time and the number of oscillation. Now, how did we get it? Time over oscillation. Time over oscillation. We have other drive quantities like voltage. We have other drive quantities like charge, electric charge. We have potential difference. These are drive quantities. Now I want to give you an assignment. An assignment I want to give you is that you go to all these quantities that I measure, go to your new school physics, turn to those, search for those quantities that I measure. I told you, you go to oscillatory motion, you see your frequency, you see your period, you go to electricity, you see your electric charge, you see your potential difference, you see and other quantities you see, then try to drive the quantity, the unit, and then try to get the dimension. So if you're able to get it from the explanation, just try it. Even if you will not get exactly the answer, when you start teaching the topic proper, you will get the right thing you needed to do. Is there any question? All right. Please do your assignment. I have done my own work. It's now for you to do your work. Please, I want to tell you one thing. If you really want to get something from me, try and do my assignment, so that if you have any issue, you can ask before you go to next class. You are permitted to use our WhatsApp number on the screen, or our email address on the screen, or use our email address. Please tell us your WhatsApp number or email address in case we need to reply you. Okay? I believe that if you're following me, before you finish this series of teaching, you will find physics very easy. Love you.